Hello and welcome once again. We're coming to you from our offices in the downtown core, and today's topic is the normal distribution. Let's begin. This presentation 6.1a, the aspects of the normal distribution, and this material is found in your textbook, chapter 6. We want to talk a little bit about the normal distribution, and we have some information on the screen here. Please feel free to stop the video at any time and take notes as required. And the normal distribution is a bell-shaped distribution, as you can see on the screen here, and this is a theoretical construction based on the limit, if you wish, of a frequency distribution where we draw a continuous curve through the data, through the histogram, and you note here the occurrences of the normal curve. And the mathematical function for this curve is given as above. And we're going to look at the case. We're going to apply the empirical rule. We have a mean of 72, standard deviation 8. And we've said that if you go up one standard deviation, z equal 1, down one standard deviation, z equal minus 1, the area or probability of getting an x value between these two red lines is 68%, which means that 34% in each part of this curve. If we go an extra standard deviation up, z equal plus 2, and 1 down from z equal minus 1, we have z equal minus 2, and between minus 2 to plus 2 is 95%, and we have the values 60, 56, and 88 here. Now we said in the previous slide that we can compute this area here, which is half the difference between 95 and 68. These are approximations only. We're going to look at the theoretical values, as you can see here. Now we look at the same type of data distribution, mean of 72, standard deviation 8. We want to find the probability of getting an x value under this scenario, x less than 80. Now 80 becomes the x value, so we compute the z-score is plus 1. Now we go to the table of normal distributions, probabilities, and you see here this is the cumulative probabilities. They accumulate from the left, as suggested by this arrow. Now in this table we go down the left column to z equal to 1. We come over to 1.0. Notice that we have 1.0, 1.02, but we want 1.00, and there's the answer right there, 84.13. And that's the area up to that red line, accumulations from the left. And the probability of getting a value on the right of that is 1 minus that, or 15.87%. Now under the same scenario, to get an x value between 64 and 84, we have the specifics coming on the screen here. 64 is our x value, z equals minus 1 to z equal to plus 1.5. Go to the table, and we're looking at the negative values, if you wish, the positive values, 1.5 z-score, and you can see here that area is 0.9332, and that's accumulations from the left. Now we go to the other value, negative 1, and you can see here negative 1.00, the area is 0.1587, and that's the area up to this red line on the left. And the area between the two, of course, is just the difference, and we can find that difference is 77.45%. Now we're going to just turn that around. Suppose under this scenario, this bottom 6% were to receive a failing grade. What will be the cutoff point for passing? Now, obviously, the area to the left of this red line is 0.06. Well, in this case, we go to the same table, but we go into the body of the table. And you can see here that 0.06 is sandwiched between these two numbers here. And you can see here between minus 1.55 and 1.56 is halfway between. So the z-score would be minus 1.555. Putting that in the formula for z and cross multiplying, we find that x is 59.6, while the passing grade is 60%. Now we're going to look at the case where the top 7% receive an A grade, and of course we have here the area to the right of this red line is 7%, Translating this, we look at the area on the left simply because of the way the table is set up. We look up 0.93. And again, these are cumulative probabilities. And we find that 0.93, again, is sandwiched between these two numbers, between 1.47 and 1.48. Now we're going to do what's called interpolation. And we taking these values here, of course. We're trying to find the z-score for 0.93, and we see a sandwich between these two numbers here. We're going to do the following. The jump across here is 14. The jump across here, 92 to 93, is 8. And we're comparing that with the jump across here, 470 to 480 is 10. And this jump here is x. X is to 10, 8 is to 14. Computing that, we find x is 5. Now we could have figured that out. It's about halfway. So z-score 1.475. Calculating x equals 81.8. The cutoff for an A is 82. And that brings us to an end of presentation 6.1, part A. We ask you to review it once again, take notes as required, and go to presentation 6.1b.